Okay, good morning again. Today we'll study something that was left out from last lecture, OS security and introduction to the internet. And please feel free to ask questions because this is very basic, okay, that we are going to study. And this is very interesting quote. Uh, Using encryption on internet is equivalent to arranging an armored car to deliver credit card information from someone living in a cardboard box to someone living on a park bench. What does it mean? Cryptography that we have studied, encryptions, are very powerful mechanism. But if the endpoints, this program or the machine M1 is communicating with the machine M2 over internet, so you can encrypt the data here and decrypt it here, so anybody in between cannot see. Okay, so this is very powerful mechanism. However, this is all meaningless provided the endpoints are not secure. So this statement just sums it up, that endpoints could be, if endpoints have all kinds of vulnerabilities, then cryptography is not going to help. So if you want to make the whole system or communicating systems secure, that's the world that we are in today. I'm communicating to you from here in Bangalore over internet to you. If you want to make everything secure, then endpoints like my machine, my router, all be secure. At the other end, your machines and uh, whatever network infrastructure you have, Wi-Fi, etc., have to be secure. Okay, all right. And now your security, you're doing course on security. Don't fall into traps of this kind. Somebody sends you money that I am stuck. Could be your friend. I am stuck in, say, some place. Somebody has gone to Singapore and got stuck. It's sending a message that I need money immediately. Send it to my this account. Don't get into all that, right? And otherwise, your mom will say you didn't learn anything in cybersecurity class. And also educate others. Since this is a first level course, I mean, then there are a lot of students of second year who have no clue of comp science topics as such. So this is more of a awareness program, security awareness program. So take the learnings from here and tell your parents or tell your friends, right? Then one password example, even the assignment you have done, that how easy it is for somebody to break. And remember that no system is foolproof. Even in the banks, there may be some insiders who will leak all this password information, okay, in hash form. There could be. And always these password files are available in public, right? So never ever do foolish things. And all the learnings we have from this class, like set very long passwords, maybe 8 or 9 characters with capital letter, small case letter, and also the special characters. Okay, you can of course make a password which are easy to remember using all this. Okay, all right. So these are the references. So we have studied in the last class concept of OS, and we'll further look into some other aspects of OS and also study OS security. All right. OS concepts. Okay, very important. This of course is not really OS concept, but OS comes into play. You write a program in any language, okay, for example C, and you have to run that program. The program is not a dynamic entity, it's a static entity. It's just nothing but sequence of instructions, okay. And then you use compiler to make it into executable image, okay. And initially you have a file, you compile it, and you still get a file which is in different form. and I would request you to please look at the ELF form. And right, so it has in this one there is something called text, and there is something called variable, static, etc. So all these fields are there. Some global, for all that fields are there, and that is executable file. Now, this executable file also may contain information regarding lot of other, programs that you are using, or maybe some library files you are using. All these are included here. But in order to run this, now note that this is compiled file also is in your set hard disk. Okay, hard disk or secondary memory like your flash drive, etc. It does not have life. Okay, does not have life. When we life, we say in the context of execution, we will say it's non-executing. But OS has to do something to make it run. What does OS do? It takes that copy and puts it into main memory, do some stuff there. Okay, changes some register values in say program counter, etc. in CPU, and then gives control to the program to run. Okay, in order to do that, so this is the basic thing that first thing is OS allocates memory for this program. So let's assume this memory is called memory image. Okay, and in that it loads various things that is part of executable file. Say for example, it creates a part of this is, of course we'll see it here, code, then static data like global variables, etc. Then it specify area for stack where it gives local variable. You define local variable, for example, as integer ABC, then ABC will come here. Okay, and if you have recursion, then of course you will create many such, and then it means that ABC is going to come multiple times in every recursion, every cycle of recursion. Then it will create multiple frames of that stack. So that concept, of course, we'll study in case we study stack overflow problem. And there is a heap and stack grows in opposite direction. Okay, heap will contain malloc kind of a dynamic data data items. Like through malloc you reserve a memory, so you create. Now there is a what somebody tries to do is as a stack overflow. Basically, you will have to either get into the area of heap, or heap can get into area of stack. Okay, or you try to overwrite over return addresses. In the once a process calls another process, there is always a return address, right, from where the control goes back. So if you override this return address, then you can have there are ways to run malicious programs. Of course, we'll look at that little later in case we study. Second thing it does after creating all these, second thing it does is open basic files like standard input, output, and uh, you know. So basically, in C input output, for input output we have concept of file and so on, right? And initializes CPU register, PCs, etc. Okay. Now, from security perspective, where is the security coming in? Now, if there are multiple processes, say P1, P2, and P2 is malicious. Okay, and when P1, okay, so basically when P1 is loaded, so P1 of course will come when it's part of the main memory. Similarly, P2 is also in the main memory, but at one time CPU is executing, for example, P1. After some time, it starts running P2, and P2 tries to access something that is in P1. It's local variables or global variables or code or whatever. Now, this is not allowed. Okay, so one process cannot in normal practice communicate with other process, and for that if a P1 has to communicate to P2 or P2 has to communicate with P1, there are ways for inter-process communication, and for that there has to be programming has to be done. In the code there must be something that will say that I want to communicate with some other process. So that's all allowed, but without all this instruction in P2 it cannot communicate with P1. So it means the memory area in which P1 executing and P2 are executing are distinct. Okay, and that this is actually in physical memory. So now when you write program, you never consider what area you are going to execute your program. So in the first generation of computers, programmers used to write what area they are going to use the main memory, right? Now you don't care. You assume that addresses are available from 0000 to maximum 2 raised power, say you are using say 32-bit processor. 32 is too small, maybe 64-bit processor or 10 so 128 processor. So let's assume 2 raised power 64 minus 1. This is the address based on your program counter size or your processor size. So this is the area you assume that is available when you write program. You don't care about where actually in physical memory this loaded. So now this area which every process assumes that it has available between 0 to say some FFFF whatever is called address space. Now every process will assume that it has 0 to FFFF, and there can be 100 such processes, but when it's actually executed this is to be translated into actual physical address. Okay, now this concept you will study when if you do OS course. Okay, so this is the concept of address space that we have, right? So but when you say something that I want to, for example, oh okay, I deleted anyway. When process P1 says that I have to read something from particular location, then actually that area, that memory is accessed, right? So it acts like for a user, for you a programmer when you're writing, so this whole thing will look like a regular memory. Let's say your address space looks like a regular memory to do, but internally OS doing this translation. Okay, and you can do of course IO operation through access to a particular memory location. That's called memory mapped IO. Of course you will study in case you do CS architecture course, and it can cause exceptions or faults when a P1 tries to access area of P2. Okay, this is not allowed until unless is programmed. Okay, that's called exception or fault. Okay, all right. So now each process will have same address space. When you write program, you don't care. You assume that from whatever 002 to something is available to you. Okay, that's called address space, and inside that, because it's compiled, and then OS creates all this area like stack, shared libraries, heap, data, text, etc. Text is nothing but your code in machine format. Data is nothing but global variable, etc., etc. Okay, heap will where dynamic memory, dynamic, like you have malloc, etc. Okay, any question? Now this is in virtual. All this address space comes into virtual addresses, virtual memory. Each program assumes that this is available. This is not real, but it gives the impression, it gives ease for programming. Like when you created VM, I'm sure you would have studied virtual machine concept. Is not the actual processor is, but it gives the impression through the programming of VM that you're running on actual processor. Okay, it's nothing but simulation of actual machine. Okay. Similarly here, each program gives the illusion that it's running it, all this memory is available to itself, right? This guy also assumes, second process also assumes for the same address, like this here. Okay. Now the question is that how is it possible? Because physical memory is only one memory, like your RAM of certain size. It means that now there has to be a translator when you're running a particular program process, say P1, and P1 say I want to access 00100 or whatever. It will look at this address because other process can also ask for this address. Okay. Now for other process, this address could be something different than corresponding to his or its own context. Okay, so when P1 asks for this memory address or data or what is stored something in, then it goes to a particular memory location, and that's based on this translation of virtual address, all this address to actual physical address. Similarly for P2 there can be different translation. So this 00100 for P1 and P2 may not, it will never point to same location until unless there is a inter-process communication or something. Okay. Any question? If I ask you questions on address space, you can answer it in the exam or not? Okay. All right. Okay. Any question? Yes or no? Are you awake?
Yes, yes, sir.
Okay. All right. So now let's very briefly look at OS security. Okay. Now we know that we have to look at threat model first. Okay, what can cause threat to OS? Now OS is not very small program, right? It's not small. You'll have to look at the size of OS. Look at Android. Android is nothing but OS with some libraries. Look at the size of it, right? Maybe 15 million or 20 million lines of code is huge. Or Linux, for example. Look at the size of Linux. Just Google and find it out. Okay. Now, when a program is so big, then it will have big threat, right? I mean, big what do you call that? Threat can be caused from anywhere. So attack surface is huge. The technical term is of course attack surface. Okay. Now all these entry points here can cause problem. For example, there was a claim that US government, FBI, has asked all handset manufacturer to provide access to anybody's phone. It means that all they wanted to create a backdoor. Some APIs based on some IP address of somebody, IP address, and using this API, anybody could see what's happening in OS, in your mobile phone. Okay, so there can be huge number of security holes. Okay, threat model could be user processes can be malicious. I mean, for example, a virus may be wanting to access it, or may also be running. But virus may be trying to access some areas, memory areas which are not permitted. Virus may be trying to access programs, okay, and so on and so forth. Okay, attacker may have terminal access to computer. What does it mean? Actually, somebody can come to your room and steal your laptop. Okay, attack of course, it is not really relevant to OS, but in general about computer. Attackers may be able to access computer over the internet. If your computer is not connected, then it's okay. But your computer is connected to internet, then anybody in the world can try to access your machine. And if you have not set the security right properly, then anybody can find out those security holes and get into your system. Okay. Software that you are running can be malicious. Even the OS programs that if you have downloaded, for example, OS from some site and you are not paid for license of the OS, then there's a possibility your OS comes loaded with malware. Now the other thing is that your OS may be outdated. You have not updated it for many versions, and in between, say for example, Linux has found out a lot of security holes and they have sent the patches. Now your machine doesn't have all the patches. Now these security holes are visible to everyone. Okay, an intruder or a cyber criminal can always find out if you have not updated your software version, and then can use those vulnerability. Hence, it is required that you update your software all the time. Okay, whenever new version is available, it should be automatically updated. And if your machine becomes too old and the OS is not updated, like if you bought machine 15 years back, then better discard the machine. If you stop receiving patches for anything, better discard it. And that's the reason you should buy software from companies that invest into all this. Okay. Third party application may pose risk. Permissions are wrongly. Now this is most important, relevant to OS. See, every file has a permission. Every user has a permission. Okay, what all can be done with user, right? For example, what rights user has. The read access, write access, or execute access, and all that. Apart from that, access control mechanism, user ID, password, and all that. Right? See, if these permissions are wrongly set for files and directories, then it can cause problem. If there is a one sensitive file, very sensitive file, which you may not want to expose to anybody, and if you have set the read and write permission, it's gone. Okay. And the capabilities, what the user can do, often it's very wrongly set. For in any organization, every user is given access to the source code, including security guard, then there is an issue. Then we apply the principle of least privilege that we studied, right? Buffer overflow problems are not fixed. The old Intel machines had this problem. Now, if you have not updated the machine, if you are using 20 years old machine, which is the case in the world, still the maximum exploited vulnerability is buffer flow, and that happened about 20 years back. And still people are using those kind of machines, not updated software. Then nothing much can be done, but cyber criminals have great time. Okay, and of course network attacks are possible. Now look at this model. This is a very general model, not really related to OS. Okay, so attacks can happen at physical level. For example, it could be hardware based attack or console access. Somebody comes and looks at your console or terminal, okay, and can get them. Or you have not set the password, you have gone for lunch, somebody accesses your machine, somebody can steal your machine. Okay, this is physical level. And then solutions, guards, vaults, etc. Then network. In general, when we say network, it means that we assume that this channel in between, which is internet nowadays, over Ethernet or whatever, how do you protect this, right? This communication. Okay. Okay. All right. So this is by encryption, authentication, filtering. Then at OS level, in the system you have OS, all you have to do is that provide patches, reconfiguration and hardening. It means that set proper permissions, proper configuration, because if configuration fault is there, then even cyber criminals can exploit that. And then at application level, application may have logic bugs, design flaws, code injection. Basically, a program may contain malware in between. We'll study that. Okay, and then methods to fix this is sandboxing, which is if you think something is could be vulnerable, then execute that in very restricted environment. Okay, and there are software restrictions. So these are the methods. Possibly some of these we'll study in this course. Okay. How does OS protect itself from malicious processes? Anybody? Any thought? A malicious malware is running. Malware is also a process, right? And OS allocates this. OS scheduler allocates this to run on processor. How does then this process which is running can also access OS? How does it protect? Okay, all right. Now this is in OS that you will study. And if you want to learn more, go to this video, which I took the class on OS some 2-3 years back. So if you go to this lecture, you will get details. So OS basically has, it works in, when a program runs, it runs in one of the two modes, and it's called dual mode of operation of operating system, right? The one mode is user mode, other is called kernel mode. Okay, user mode is all programs that you applications that you run, and kernel mode is restricted mode, because when there is a kernel mode, then OS does certain things. It means that OS process is invoked and it runs over the hardware. Otherwise, user mode, the user process runs on the hardware or processor or CPU or whatever you call. Okay, so in user mode, there is only limited hardware access, right? You can't do everything. Only something that's required for that process to run is, a process can only do that. But kernel mode, complete full hardware access is there. Okay, there's a one distinction, right? So when you do system calls, see, user processes can only can only access hardware through system calls. Okay, all right, because OS will finally allocate the process, and suppose a process wants something to be done, say accessing some, say for example, you want sending a network packet. See, your IP is TCP or whatever is, our application is sending byte stream, TCP application, bit stream, and then that has to go into internet, right? So every time one certain number of bits are available, the user process will use some system call and give this data to kernel, and kernel will finally send it to internet through Ethernet card and so on and so forth, right? Okay, so all right, so this kernel, this is kernel or OS, it has only limited entry points. Okay, and that is through system calls, syscalls we call. And there is one more hardware bit in order to do all this, right? Because hardware has to put some restriction that this is kernel process or user process. How does it do? There must be something in hardware. And this is just one bit that does the magic, is called mode bit. Okay. Okay, so when mode bit is 0, okay, then when hardware sets this bit is 0, then it is in only kernel programs can run. And when it is a 1, then the processor will run only user programs. Okay, all right. So anyway, but this is just uh, something to tell you. But you can see now that all the process, like whether compiler or word processing, like Word program or whatever, browser, email, web server, all are going to use OS library, which internally use system calls. Okay, so now system calls are only set of system calls. Some can be very terse or difficult to understand. So there is OS library has been created by Linux and many other applications. So this OS library, portable OS library, is much higher version of these system calls. They internally use system calls. Okay, so to note that everything goes to hardware through system calls. Okay, all right. And these system calls are forking a process to multiple process, exiting, executing, open a file, read a file, write a file, close, pipe, get PI, process ID, alarm, sleep, and many more. I have just written just a few. Okay. So basically, all security topics that if you are really interested, you can go through any book. It's like memory protection, supervisory mode, which is nothing but kernel mode. User mode to kernel mode switching, this process, accountability, okay, what all each process can do and is accountable for that. Reference monitor is nothing but what all can be accessed. All access must pass through certain pass through access monitor. Access matrix, like this part we will possibly study is you know what all what a user what access privileges each process has. Okay, and similarly ACL is one such example, and second is called capabilities. Both are the same thing. Access, it gives access right, but perspective is different, right? What each process can say, if you club them around process, sorry, each resource. So for example, printer. Each printer, who all can access? Say for example, Ravi can access, or for example, you can access, Alice can access, right? Okay. Okay, so that's one way of looking. Second way is that what access I have. I have access to printer. I have access to, say for example, LAN card. I have access to flash drive, whatever, right? So these are two ways, and accordingly we call them either access control list or capability list. Okay, and then object permissions and file based access control. Oh, okay. Can you see the screen now? Hello.
Yes, sir.
Disruption in between, right? Okay. All right. Okay. And there is something called set UID and user ID. Please look it by yourself. Okay. Uh, Possibly you will look at it. Directory permissions and role based and mandatory access control. Okay. So OS security summary. We have address space. We have access control like password, biometrics. This all we studied. Address space we have studied. Reference monitor we have studied. Okay, complete mediation or monitoring of all access requests. Okay, protection from stack overflow. Okay, we will possibly study this. Use of antivirus software, permissions, properly use permissions, right? This is a major issue. If your system admin guy is not right, or if you're not setting these permissions right, then there is a issues, right? Capabilities, each user has certain set of permissions. Now what all user can do, that also has to be properly fixed. So these are very common ways of providing security, and you of course use of cryptographic tools and techniques, security policy, not polity, security policies. So every company has to have some security policies. Okay, similarly every machine or every system there can be security policies, but in general it's related to an institution and some organization or department could be. And there must be some intrusion prevention methods, right? If somebody is trying to get into OS or system, how can you detect this? We'll cover this topic later. Okay, some other points. Safe security practices like long passwords and don't share password, etc. All this, avoid phishing techniques. I mean, if you get an attachment on an email and email title is, this $1,000 is for you, and you have still you double click on it, then all that can be said is that you are inviting malware to your machine. Use secured communication protocol, like never use HTTP. When you have HTTPS, it means that it's using encryption. Okay. Configure OS to minimize the surface attack surface. Okay. Disable or unused services. Configure your system parameters properly. Check permission. Keep system or software updated. That's very important. All right. So this is all about OS security. Next 12 minutes, we'll look at internet. So that's all about OS security. Although this topic is very big, but we need to cover more topics. So we'll now onwards we'll move into network security, and sometime or other we'll come back to some aspects of OS security. Okay, what is the security Alice wants in isolated island? She is in island, she is alone, and there's a laptop with her. There's no internet. There's nobody else. She's somewhere here. Somehow she reached there. What does she need? She needs nothing, no security. Okay. If you don't have contact with outside world, you don't need any security. That was the case about 40 years back or 30 years back. We never bothered about any security. Now maximum attacks, or security that you need is cyber security. Whatever money I have is either in the form of cash that's in bank, or my other digital assets like my stocks or mutual funds. Okay, all these are in the digital form. and I can lose this in cyber attack. All my money can go away. And if you look the banking rules, they will say maximum they will repay for it is 1 lakh of rupees. I may have 1 million rupees in my account, but if cyber criminal steals that because of my mistake, then it's all gone. And so the cyber criminal need not be in Bangalore. It could be anywhere in the world. Okay. So now this is very important for you to educate your parents, your friends, and relatives to use proper or secure oneself digitally. Okay. Of course, that comp science is not, the UI aspect is still not to the extent that, very poor people can protect themselves, right? I mean, it's very common to see, a construction worker sharing the password to everyone, right? And in fact, they don't know how to operate ATM. They will say, this is my PIN code and please use it and give me, take the money out. And all those things, the practices are happening, which cyber criminals are, of course, enjoying. So every asset, whole point of telling you is that most of the assets that we have today are in the digital form. And more connections we have, less security we have. This is a perfect thing, right? Okay, because anybody in the world can connect with us, right? But connection also gives us power. Okay, so now internet is most beautiful thing that you will see today has seen the exponential growth. No other technology like pods, radio, or even some X.25 or any other technology has not. These came and sustained for some time, still existing. Say for example, ISDN or Sonnet, they still exist, but it exists only for limited purpose. And the growth has also been limited because none of us have used any of these, excepting for pods, telephone, which is nothing but a home telephone, line telephone. Why internet has grown exponentially? Did you ever think about it? Anybody? Okay, let's look at 3 laws. Be very careful, huh? And be attentive. If you are sleeping, please wake up. Because this next 10 minutes will be lovely, right? I mean, you will enjoy it. First law that we are looking at is Nielsen's law of internet bandwidth. Every year, user bandwidth, now you note the word user bandwidth, grows 50% per year. Now, initially when I started, it was less than 1 kbps, kilobits per second, using modem. Move it to 10 kbps, 100 kbps, then 1 mbps, and 10 mbps. Then right now I'm using 40 mbps in this connection. And then now my another connection is 100 mbps. Second Ethernet, second internet connection at home, and has moved to 1 gbps. Now this is what is available at home today. At the almost same cost. Actually, cost is rather reducing. Okay. So now for the same amount of dollar, bandwidth is increasing year on year. Oh, lovely. Okay, today most of us having 100 mbps connection, which was about 10 years back, it was costing more than 10 times. This lovely law, right? Why did this happen? Because technological advances. And user, the internet becoming popular, it has further reduced the cost, increase in bandwidth and all that. And one important thing is use of fiber instead of copper, right? Fiber can carry terabits of information on just fiber, single fiber. Optical switching of signals, advance in switches and routers, processor technology, okay, reduce cost of processor and switches, bandwidth hungry applications, simplicity and flexibility of internet technology. All this has caused reduction, increase in bandwidth. 100 Mbps. Pardon? Somebody asked 100 Mbps. Okay, all right. So this has caused, and of course, improvement in wireless technologies. Like 5G, etc. Okay, all right. Second important law is called Moore's law. My first laptop that I bought in 1994 costed me my 1 year salary. And somebody told me, why did you buy a laptop instead? You could have bought 60 by 40 plot in Chennai. Okay, that was true at that point in time. Okay, that was a cost of a laptop, something like, at that point in time, my salary was 7,000 rupees a month as IT faculty member. And then the laptop costed about 30,000 rupees, more than a year salary, like close to 1 year salary. The 30,000 rupees in US, and in India, it was over 1 lakh. Okay, so that was the thing. And that was very tiny laptop. So now this very important law says that number of transistor on a chip doubles every 18 to 24 months. And this was given by Gordon Moore, who was co-founder of Intel. And this law is true for 50 years. It means that if you buy a laptop today or processor today and buy next year, for the same rupees, you will get 2 times transistors in it. It means that IC or semiconductor, the number of transistors in a chip is almost doubling every 18 to 24 months. And this has been true. So you are getting more and more processors. And now what we are doing, instead of single processor on a chip, you have, say, 64 processors on a chip, or maybe 1024 small processor on GPU, and so on and so forth, right? Okay, so transistors getting smaller in each generation is almost, we are closing to reaching, now we are almost reached towards the limit. Now we have now 5 nanometer processors of the technology that we are using now. Like Apple's M1 chip uses 5 nanometer technology, and in fact now since then there is still further reduction in transistor dimension. So a small chip may contain this size chip. This is actually bigger. Actual size may be smaller. 16 billion transistors. And we can see the processor technology evolution is very fast paced from 1970s onwards. And now we are somewhere here. And the processor is generating heat. And if we continue to reduce the size of transistor, the heat will become so much that we cannot manage it, right? And to say that if you continue to increase integration, then at the same pace, then we'll reach the heat generated by sun. So now what we are doing is that instead of reducing the dimension of transistor, we are moving towards parallelization. So that's the reason you say 4 processor chip, 8 processor chip, 100 processor chip, and so on and so forth, right? Okay. All right. So that was Moore's law. And third law is Metcalfe's law, which we'll study in 2 minutes and we'll close. Metcalfe's law says that more connection we have, more powerful the machine is. Okay, more power we have. So if you have 20 computers that are interconnected, it will look like this. And look at the power of that, because each Connection gives way of communication and way of doing computing. Okay. Okay. So we have millions of computers or billions of computers interconnected through internet. Look at the power. Okay. All right. So it says that value of the network increases in proportion with the square of the number of nodes. Okay, the value that is a power of that is depending on number of connection. More the number of nodes or connections, the square of that is the power. If you have just 10 machines, then power relativism is proportional to 100. If there are billions of machines, then look at the power. Now can we combine these three laws? Yes. And that is what is happening. Here we have improvement in processor or transistor or semiconductor technology, the Moore's law, Nielsen's law. There is a, every year bandwidth is also increasing, and Metcalfe's law. Because of these two, there's a lot of connections that are happening, and that overall gives overall power, right? So now we can see combined effect all three that we'll cover in the next class. Okay, any question? All right then, thank you.